Hello and welcome to this quarterly EMC accreditation training regarding Docker and containers. My name is Jonas Roslin and this presentation has been co-created by me and Matt Cowger. Let's start with a basic overview of how apps have fundamentally changed in the last decade. About a decade ago, and this is still true for many applications being deployed today, apps were usually monolithic. They were contained in one large blob of binaries and libraries. They were usually built on a single stack, such as .NET or Java. They were usually long-lived as well, so patches and new functionality usually took a long time to develop. Mostly they were deployed to a single server as well, so it looked something like this. So what you can see here, the cloud represents all your clients and customers and users for the application, which is in the middle, where you have integrated all the functionality into a single application, and then you store some data in the backend. Some of these applications you might say, well, we load balanced them so they weren't just deployed on a single server. Well, even though they were load balanced, they were still monolithic. So it might have looked something like this, where you had all your clients, customers, and users connect via a load balancer. You would then have a monolithic architecture behind that load balancer, and then you would store data somewhere. Compare that to today and how applications are created today. Applications are constantly developed. You will not see patches and functionality updates to a huge blob of a specific application usually, but you would see updates and security patches and things like that for each part of the application. And this is a big change from the monolithic application structures. So new versions are usually being deployed often, and the entire application is built from loosely coupled components instead of tightly coupled components in a monolithic application. Usually they are deployed to a multitude of servers as well, and the pieces of the application talk to each other. So your application might look something like this, where you have your users connect to a presentation layer. That presentation layer is then connected to a shopping cart, a money transaction layer, a library of some sort, and you're storing data in different areas. So how do you handle all these different small parts? Well, let's start with a useful analogy. Let's say you're a shipping company and you're really good at shipping pianos. You're not just good at it, you're great at it. You're the best piano shipper in the world. Then you have a customer of yours come up and say, hey, can you ship some potatoes with those pianos as well? Then you say, yes, of course, they'll fit right next to the pianos. So it will look something like this. Then you have another customer that would like you to ship some whiskey as well with the potatoes and with the pianos. It will look something like this. So as you can see, it starts to get a bit cramped and they're starting to fight about space and functionality as well. And things starts to break when you see that the whiskey is starting to spill all over the piano. Your crew is starting to wonder how to handle all these differences between the goods, looking at the size of the goods, looking at the form of the goods, also looking at the requirements to keep it safe and stable during transport to make sure that nothing falls overboard or that nothing breaks. And you also want to be able to transport it using different transport methods. So what to do? Well, this was solved about 50 years ago when something called the intermodal container came into play. The intermodal container looks like this, and I'm sure you've seen a lot of these already. They are all over the world. With this, you can ship everything from a piano, potatoes, whiskeys, cars, motorcycles, you name it. And not only can you ship everything, you can ship it at the same time, and they can actually be on top of each other. So now you can ship pianos, potatoes, and whiskeys at the same time. Of course, you can also use different transport methods. It doesn't have to be a large container ship. You can use the same container to continue the transportation of the goods on the road or on the railroad. So what does this have to do with software? Well, it's similar. You remember when we talked about your application? Your application is built out of a lot of small parts. All these small parts are called microservices. So you have a web server, you have some sort of database server, you have a shopping cart service, and maybe some big data analytics. I am pretty sure you can install this in a production data center. But would it look the same if you ran it in your development environment? Could you set it up exactly like you would in a production environment? Or what about in a lab? Can you set your production environment up in a lab so you can test out a few things? Could you deploy your application just like you have it in a production environment in the cloud somewhere, either private or public? To make this easier, we look at containers. Containers make your application portable. It looks the same everywhere you run it, no matter where you run it or how you run it. It looks the same. If it's in a lab, if it's in your dev environment, if it's in a cloud, it looks exactly the way it should do and the way it does in your production environment. Another benefit of containers is that you don't need to install the application dependencies on your host. This is where the whiskey and piano analogy works, because if you have different dependencies of your different application parts, they start conflicting with each other. Let's say you have different versions of Ruby or Python or Java that you need to have installed to have your application up and running. That's really hard if you don't have containers. When we look at Docker, Docker is just one of the container standards. There is a bunch of them out there, but Docker is definitely the most popular one. And due to it being so popular, it has built a large ecosystem around it. Let's look at some Docker facts. Docker was launched in March 2013. This is about 2 years ago during the recording here. They right now have over 100 million downloads of the Docker engine. There are over 75,000 Dockerized applications. That is applications running in Docker containers. 75,000, that's a lot. There are over 150 meetup groups around the world focused on Docker. So no matter where you live around the world, you will most surely have a Docker meetup group quite local to you. There are over 100 case studies from companies such as eBay, Rackspace, New Relic, Spotify, Cloudflare, Yelp, and more. When you look at a container in a Dockerized format, it makes your application very shareable. The entire needs of an application is defined in a text file called a Docker file. You can see an example here. A Docker file is very, very simple and actually easy to read, even though you don't know Docker. This is an example Docker file where we build a container based on the binaries and libraries that you get from a Ubuntu distribution. After we have that base, we want to install an application called a Redis server. Then we want to expose a port. We want to open a port, which is the port 6379. And then we have what's called an entry point, which is the application that we want to start in this container, which is the Redis server. These 4 lines equals an entire container that is actually production ready. So containers contain everything your application needs. It contains all the binaries that you need and all the dependencies of them, all the libraries that you need and all the dependencies of them, and a file system so you can actually use it as well. Then containers use the host for certain things, like networking, for instance. And of course, it needs a kernel to actually run applications, so it uses the host kernel for that as well. So there's no real need to run an entire operating system like you would in a virtual machine to just run an application. With containers, you start your applications in a fraction of a second. You have no BIOS or operating system boot up to worry about. So with containers, you can run pretty much any application that's out there. If it's not already out there, you can build your own. So in summary, containers are pretty awesome. You can use them for your next application that you're developing. You can use thousands of already existing apps. You will most probably find exactly what you're looking for already. They will always look the same no matter where you deploy them. They are always portable, so you can always use the same image, the same container on your laptop, in your lab, and in production. And they leave your host OS clean, so you don't need to worry about all the dependencies like Java, Ruby, and Python between your application parts. For some further reading, please see docker.com, Docker's website, which will explain a lot more in depth about how Docker works. Thank you.